Hello friends, this video on aldehyde ketones and carboxylic acid part 7 is brought to you by examfear.com. No more fear. Now let's understand some of the method of preparation of aldehyde ketones. What we have done till now is we have learned what is aldehyde and ketone, and also we have learned how to write the structures of aldehyde ketones, how to name aldehydes and ketones, whether it's common name or IPC name. Now we'll study some of the methods to prepare aldehyde and ketones. As I told, the way I have bucketed this whole chapter is aldehyde and ketone is one part and carboxylic acid is one part, because aldehyde and ketone has a lot of similarity. Whether you talk about the chemical property, physical property, or method of preparations, they have similar properties. Right? So for aldehyde and ketone, we can prepare by oxidation of alcohol, dehydrogenation of alcohol, ozonolysis of alkenes. We can also prepare from alkynes. We can also prepare by heating calcium salts of carboxylic acids, and we can also prepare from the Grignard agent. In fact, there are other ways also to prepare aldehydes and ketones, but we'll focus only on these four aldehydes and ketones. We'll study separately some methods which are used specifically for aldehydes and some for ketones, but these methods which I'm discussing, these 6 methods which I'm discussing now is for both aldehydes and ketones. With these 6 methods, you can prepare both aldehydes and ketone. And just let me repeat it. This is my aldehyde. This is my carbonyl group. With the H is my aldehyde, and carbonyl group with 2R is my ketone. And this is how it looks actually. If you see, this is the 3D view of aldehyde and ketone. If you see, this is all in one plane. This carboxyl, we have discussed, right? This carboxyl group is all in one plane. It's all in one plane. So let's discuss the first method, that is oxidation of alcohol. So it is oxidized by esterified K2Cr2O7, that is potassium dichromate. K2Cr2O7. It's a strong oxidizing agent. You can oxidize. So if you take 1 degree alcohol, you get aldehyde. I'll write here first 1 degree alcohol, and you oxidize with the same reagent in acidic medium H+, you get aldehyde. And if you take 2 degree alcohol and you again oxidize this, you get ketone. In fact, we'll see there are so many oxidizing agents in the market. For example, chromic acid, chromate salt, dichromate salt, permanganate, PCC, that is pyridium chlorochromate, and PDC is pyridium dichromate. There are so many oxidizing agents you can use. K2Cr2 is the most common use. You can use any of the oxidizing agents. So I'll just take you through this example for the alcohol. For example, I have this alcohol, CH3, CH2OH. Now if I oxidize this in presence of my oxidizing agent, in this case I'll take K2Cr2O7 and H+, maybe sulfuric acid, what I get is CH3COOH. This is what you get. But the ketone, this part I can show you. If I take, let's suppose, 2 degree alcohol, something like this, the OH, and I oxidize this. If you see, this is a 2 degree alcohol, because this carbon is the hero carbon attached to 2 other carbons, 2 degree alcohol. When you oxidize this, you get CH3, C, this becomes double bond O, C2H5. So if you see, this becomes ketone, right? This is butanone, right? 4 carbon butanone, and this is ethanol. This aldehyde, this is ketone. If you see, that's why if I took 1 degree alcohol, I got aldehyde. If I take 2 degree alcohol, I get ketone. Correct? Hope you'll remember this. 1 degree alcohol, aldehyde. 2 degree alcohol, ketone. it should be, if you take 3-degree alcohol, you won't get anything because there has to be a hydrogen to be removed here, right? So if you take 3-degree alcohol, you will not get anything. So it has to be 1 degree or 2 degrees. So you take 1 degree alcohol, oxidize it, you get aldehyde. You take 2 degree alcohol, oxidize it, you get ketone. The next is dehydrogenation of alcohol. The reaction looks similar to my oxidation of alcohol. Here also same similar stuff. If I have 1 degree alcohol and if I do a dehydrogenation, that is you remove hydrogens, you get aldehydes. And if you have 2 degree alcohol, you remove hydrogen, that is dehydrogenation, you get ketones. 3 degree alcohol will not work here. So here what we do is we take alcohol, in this case I'll take 1 degree alcohol, and then what I'll do is, since it's 1 degree alcohol, it will have hydrogen, alpha hydrogen. I'll heat this with a heated copper or silver at a very high temperature, maybe 580 Kelvin. And you'll get the alcohol and hydrogen back. For example, the common equation for this is you have RCH2OH. This means, this implies this is a 1 degree alcohol, and you have this copper at 580 Kelvin. You get RCOH, and hydrogen is out. If you see, this hydrogen and this hydrogen is kicked out, called dehydrogenation. If you want the reaction, I have CH3 CH2OH. When it reacts with copper at 580 Kelvin, it gives CH3 COH and hydrogen gas. So if you see, one hydrogen from here, one hydrogen from here is kicked out, and you get this aldehyde. Let's see the same reaction for now ketones. 2 degree alcohol, again the same, you heat at 580 Kelvin. So if you see, the reaction is, I have R, I have CH, again I have R, and then I have OH. So in this case, if you see, this is a 2 degree alcohol. You again, here also you heat with copper at almost 580 Kelvin and 573 to be specific, you get RCOR. It can be R dash, just to give a general equation, plus a hydrogen is emitted. So here also this 2 hydrogen comes out, right? A typical example can be, I have CH3, CH, OH, I have CH3 here. I can take anything else also, it will be CH3, same 573 Kelvin. This is exact, but you can take any of this temperature, it won't make much difference. Yeah, and hydrogen gas is kicked out. So you can do any of these. Either you can use this copper and do a dehydrogenation, or you can use oxidizing agent to convert alcohol to aldehydes and ketones, right? Any of these methods can be used to convert alcohols to aldehydes and ketones. The next is ozonolysis of alkenes. Please note, here we do ozonolysis of alkenes, not even alkanes, it's alkenes. So here my alkenes are oxidized. You can oxidize this to form ozonide, and then it is then reduced. It is then reduced by hydrogen or zinc or acetic acid. There's so many ways to reduce it to form either aldehydes or ketones. Now, whether it will form aldehydes or ketone, that depends on the number of alpha hydrogen. So if it has 2 alpha hydrogen, it becomes aldehydes. If it has 0 or 1 alpha hydrogen, it becomes ketones. I'll show some examples for this. But first, let's see the reaction mechanisms. For example, I have R, C, H, double bond, R, C, R dash. Right? Let's suppose I have this compound. On this, first I'll use ozone, correct? So you have to react with ozone in presence of CCl4. So what will happen is ozone, if you see, is something like this, right? So one part has plus charge, one part has negative charge. The one which has negative charge will have 3 lone pair of electron. This will have 4, and this will also have 4. Now what will happen is, this is a double bond, it has a lot of electrons. So this guy, this double bond will attack on this oxygen with a positive charge, and the one with the, now since this bond will break, this carbon will get slightly positive charge, this negative charge oxygen will attack this carbon, correct? So with this, what you get is, so what I've done is, on this I've attacked ozone, O3. So what this you get is RCH, this double bond will break, and you get R dash here, and then you get something like this, correct? And this is called ozonide. Now on this, in fact, this will tautomerize, actually this will tautomerize to form ozonide. This is not ozonide, sorry. Tautomerize to form ozonide, where oxygen will come here. They will rearrange themselves. Yeah, this is my ozonide. This is my ozonide. Correct. So I have got my ozonide. Now on this, what I'll do is I'll reduce it with hydrogen or zinc. So with this, what you get is, this becomes R, C, double bond OH, and R dash, C, double bond OH. This, if you see, right, what happens is this becomes double bond and OH, and this becomes double bond and OH. This goes off. Correct? It also gives water as output. So if you see here, it had 2 alpha hydrogen, this and this. See, it has 2 alpha hydrogen. The output I got is aldehyde itself. I got only aldehyde as the output. Correct? So if I'll take one scenario where I have 1 or 0 alpha hydrogen, in that case I'll get ketone also. So if I have 1 alpha hydrogen, then I'll get ketone and aldehyde. So I'll show you the scenario. For example, I have CH3, C, H double bond C. Here I have CH3 and I have CH3. And I'll do ozonolysis of this. So after tautomization, what will happen? I'll get something like this. Correct? And now if I do a reduction, what will happen is I'll get this compound. Let me draw it here. Yeah. This one. CH3, COH, right? Plus this compound CH3, COCH3. Correct? This is my aldehyde, this is my ketone. Correct? So the only thing is, if you have a hydrogen here, it becomes aldehyde. If you have alkyl here, it becomes ketone. So if both are hydrogen, you get both aldehydes. If one is hydrogen, one is alkyl, you get one aldehyde, one ketone. And if both are alkyl, then you get both as ketone. Correct? If you, instead of H, you put some R, this becomes R here, and that becomes the ketone. So that is the logic. If you want, I can draw a case where I have 0 alpha hydrogen. This case I can draw. So here I'll show you that. C2H5, yeah. we get both as ketones. So with this, what you get is correct. This is what you get. Now on this, if you add the reduction, what you get is CH3. This is one compound, this particular part, and the other is this guy. And some hydrogen gas, water actually. This is the output. If you see, both are ketones. So it all depends on the number of alpha hydrogen. If you have 0 alpha hydrogen, you get both ketones. 1 alpha hydrogen, 1 ketone, 1 aldehyde. 2 alpha hydrogen, both as aldehyde. Correct. This is the method of aldehydes and ketone preparation by ozonolysis of alkenes. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.